Welcome to Brain Vision.
Let's use the chain rule to find some partial derivatives. Now, if we look at the first equation involving z, we see that z depends on u and v. And then if you look at the last two equations, you see that u and v both depend on s and t. So this will help us with our chain rule. So how do you go from z to s? Well, looking at the tree, you have from z to u and then u to s. And you could also go from z to v and then v to s. Now let's go ahead and compute these derivatives. Derivative of z with respect to u, so that'll be secant squared u over v, and then by the usual chain rule, multiply by the derivative of u over v with respect to u, that'll be 1 over v. So this is all for the first derivative here. Then next up, we multiply that, derivative of u with respect to s, that's 2. And then derivative of z with respect to v, so this one will still have the secant squared, but now we multiply by the derivative of uv to the minus 1 with respect to v. And then finally, derivative of v with respect to s, that's 3. So we can go ahead and just simplify this a bit. So that's 1/2 of the final answer. So now we will go on and use the chain rule again, but this time to find the derivative with respect to t. So using the tree once more, we go from z to u, then u to t. And we could also go from z to v and then v to t. So fortunately, these first two derivatives we've already computed in the previous part. These are the same as these, so we could just go ahead and replace those. And then now derivative of u with respect to t, that's 3. This one we already computed over here. Negative u secant squared u over v squared. And now this time, derivative of v with respect to t, that's minus 2. So the last thing here would be just to clean this up a little bit. 3 secant squared over v. And then here you could cancel out those minuses. That'll give you a plus 2u secant squared. And this part is over v squared. And there's our final answer.